Welcome surfers, it is Joel and this is Rustlers. In today's video we will explore new concepts like binding, mutability and shadowing in Rust. In Rust all variables are actually bindings. That means that when you create a variable you are binding a name to a value. So if I write something like this, let x equal to 5, in this case the name x is bound to the value 5. But, and this is very important, by default variables in Rust are immutable. Once you bind a value to a name, you can change it through the rest of the code. Let's see what happens if we try to change an immutable variable. If I write x equal to 6, I can try to compile this code. As you can see, I cannot assign twice to immutable value. This won't compile. But why? Because Rust wants to make sure your data doesn't change accidentally. It's all about safety and predictability of your code. But sometimes you do want to change a value. To do that, you make the variable mutable using the mute keyword. So I can comment this line. Perfect. And I can create a mutable variable. Let y equals to 5. But this time is mutable. Okay. This is a compile error. In this case, I can assign another value to the same variable. Try again with cargo run. And as you can see, there is a warning because y value is unused, but the compile don't have any problem with this change of value. Now we can also print the value of the variable. Y. Okay, and let's see what happened. Perfect. I have a variable named 6. Perfect. This time the compiler don't say nothing about the mutation because I explicitly saying I want that y is a variable that is mutable. In Rust there are no silent mutation, so every change has to be declared with this specific intent. Now we can switch topic. There is another very interesting feature in Rust called shadowing. Instead of mutating a variable, you can redeclare it with the same name. In this way you effectively replace the old binding. So if I write something like this, let name equal to Joel, I can rewrite this variable in this way. Name dot length print line the length of the name is the result. Perfect. The length of the name is 6. In this case, this is not a mutation, because it's a totally new binding. The old name, Joelle, it's been shadowed. This allows you to safely reuse variable names when transforming data step by step. Shadowing is also very useful for changing type. As you can see, the first name was a string slice, this one, and the second name is a integer, the length of the first variable. Now let's talk about constants. I can declare a constant using the const keyword. Max score I32, an integer, equal to 100. Perfect. Inside the main function I can access this constant and I can print it. The max score is max score. Perfect. Let's try again with cargo run. And as you can see, I can access this integer through another function. Constants have very specific characteristics. First one, a constant is always immutable. Second one, a constant must have an explicit type. I can't write something like this. The compiler can't accept a constant without a specific type. So I can add again the type and the code compile without any problem. Third, very important characteristic. A constant must be known at compile time. In any case, uppercase also this. Perfect. These are the three main characteristics of a constant. In this specific example, I declare a global constant, so I can use them anywhere in the module, inside the main function or inside any other function of this module. By convention, constants are always written in uppercase snake, so uppercase letters with an underscore as divider. For today's video, it's all. See you in the next atom, and don't forget to keep your thinking cap on.